Very good morning. Can you hear
Good
me?
morning, sir.
Good morning. Good morning. So, welcome to this online artificial intelligence class, session 8. So, in this class, what is that we are trying to learn is about how do you play a tic tac toe game? What are the basics that are needed to play any game? And how can we develop a heuristic for developing this type of games? And what is the strategy? How do you represent these games? How do you play these games? So whenever we play a game, like whenever you try to program a game, what is the first thing we need to keep in mind is, in general, the entire strategy that you develop will be lying on three aspects. When two players play a game, so I play a game like see, I think I need to mute. Anyway. So every time when we play a game, we have three outputs. Whether the computer wins or you win or they will go for a tie. So every time when you have a program online, the program intention or whatever program that the people develop is meant for the computer to win. So that you have a better strategy, then there is a chance that you can win. And both of them are performing equally better. There is every chance that the output can be tied. So what is that we do in this class is very simple. It's a very simple class today. Like what is that we have done in the last class, and see the general strategies of tic-tac-toe game in the terms of what intuition you need to have when you just implement these small games. If you remember the last class, we have seen various components of artificial intelligence. If somebody wish to design a AI system, what are the important and mandatory components that you need to have for developing a system? And we also see in what are the foundations of artificial intelligence. Since we say, if you open your textbook, we say whatever machine learning is, how does the machine understand is the way in which your brain understands. How does your machine represents is in the terms of how does your brain represent a problem. How does your brain manipulates the neurons, the same way your machine also manipulates the neurons and get the output. This is what the entire theme of the class yesterday. Today's class also will be going in the same intuition, but in the context of how do you play a game and what are the strategy in general we need to have when this tic-tac-toe game is played. So this is what the agenda of the class is. So a summary of the last session, we have discussed like what are the foundations of AI and what are the components of AI. Then we'll see the intuition towards playing this game, and we try to have a heuristic for tic-tac-toe game also. So what should be there for is heuristic? What is the definition of a heuristic? And what are other components that heuristic must have? So we try to understand the definition of heuristic in the first unit itself, because the heuristic is a part of the second unit. But if you understand the way in which heuristic is needed for the algorithms, then we can understand the subject very well. So in the next slide, what is that I kept is two topics that we have discussed in the last class, like what are the components of artificial intelligence. Yesterday I have discussed three main components are there. Like we need to have a knowledge database, we call it as a database, and we need to have inference mechanism, and we need a control strategy also. This is what it will come in the next slide. Just see this. So we need a statistical data for our classifier to predict something that will happen after some time. For prediction, the most important component is a database. The database we call it as a knowledge base in artificial intelligence. So every time when you are trying to build a classifier, you need to understand that you will be moving from one state to other state. Initially, we have a state where the requirements are not clear. Then we move to another state where some requirements are clear so that we can take some decision. we go to the other state in such a way that my requirements are more clear and I can able to take a decision with more confidence. So on and so forth until unless there is a clarity in information, then I can take a decision. I will stop there, and I stop there. That is called as your inference. That is the output of the system. So who is making you to move from one state to other state is the control strategy. So the control strategy can be imagined as an algorithm, or control strategy can be viewed as a classifier or any other thing. But control strategy, the basic requirement is it has to move from one state to other state based on the way in which you reach your goal state. So inference engine is the most important component of artificial intelligence. The reason is every time inference engine, what it will do is it will interact with people or interact with not only people, it interact with the systems, and it process the natural language processing statements in some cases. In some other cases, it has to process images. In some other cases, it has to process videos, and then it has to provide an inference. Inference, we can call it as an output of artificial intelligence at the particular moment. So when you get an output in the terms of inference, there is a chance that the inference is 100% true, or inference is true with respect to some value. That value we call it as a probability value. So every time the inference may not be true. That is the reason if you see your expert system design, we have a truth and belief system where every statement will have some truth. Like I said, there is a chance that you will get a rain at 10 o'clock is 0.8. There is a misbelief also. Misbelief is 0.2%. So there is a chance that you have a rain at 10:30 is 0.6. So that is what the inference of my statement. So there is every chance that there is no rain in the terms of 0.4 also. So that is what the inference says. Inference with 100% guarantee, inference with some probability is also the output of artificial intelligence. So many other components are there. The components of artificial intelligence will come in a detailed manner when you read something about an expert system. So as far as the first unit is concerned, these three are very important. In these three, this knowledge base is very important. Knowledge base, I'm talking in the terms of database management system. I'm also talking in the terms of statistical parameters or statistical values, which will not change with respect to time. So every statement, the probability is 100%. So if I say I have a fact that there is a rain at 10 o'clock, if I say that is a fact, the meaning is the probability is 100%. Definitely there is a rain at 10 o'clock. But every time when prediction happens, we cannot guarantee that 100%. So what is that we do is we add some certainty factor to that statements. So components of artificial intelligence is very important in the context of external exams. Even when you go for some challenges in the terms of AI, whether it is Oracle challenge or IBM challenge, these control strategies are very important in these components of AI. That is the reason this control strategy itself is a unit in your AI. That control strategies will come in your second unit. So control strategies can be BFS algorithms or DFS algorithms or A-star algorithms or A-star algorithms. Many other algorithms are there. Based on the application and based on the amount of data and based on the amount of features, you have to take a particular control strategy. You are given 100 images and you are asked to find out which image is pertaining to an animal and which image is pertaining to a vehicle. Then what is that we do is we try to collect the features of what are the features of animals that distinguish between the cars, what are the features of cars or vehicles, and then we try to find out. So when the features are less, your machine learning algorithms, the job is very easy. If I ask you a question like what type of animal it is or what type of vehicle it is, then the problem will come. So then what will happen is the number of features to find that will increase. Then the problem complexity increases. So that is the reason when you try to understand artificial intelligence, you need to have three things in the mind. Like artificial intelligence can be implemented either with machine learning or deep learning. So there is a concept in between this machine learning and deep learning. We call it as a neural network. Advanced part of neural network, we call it as a deep network. The reason is deep means you are having more layers. This is what I wish to share. So yesterday class we have discussed also about the foundations of artificial intelligence. Like the basic foundation of A is mathematics, and the basic necessity of artificial intelligence is linguistic. These two are very important because every time when you design a classifier or when you try to design a system, we are measuring each statement in the terms of certainty factors, in the terms of probabilities. See, I am suffering with cough and running nose, and also I said I am suffering with a headache. There is a chance that you get a fever. But interestingly, if you see that WHO website and you consider mycin also, now what does your mycin is telling is your fever and body pains may lead to COVID-19. So the inferences that you have taken for a particular patient may not be the same inference for the other patient. Somebody is suffering with cough and running nose, you said there is a fever, but the same symptoms for the some other patient may not be the same conclusion. So every time some patient says I have a fever and throat pain, I say it is a fever, I take that fever guarantees 0.5. Some other patient comes and he is suffering with cough and running nose, the output is a fever, he is suffering with a fever, then this 0.5 will become 0.55. So on, the belief of the statement will increase or decrease with respect to time. So the belief or disbelief is represented in the terms of mathematics. That is, we call it as a probability. So the mathematics is a vital component of your A. It's very important because you represent the uncertainty of data in artificial intelligence by using mathematics. You take a statement and give a statement, you take the input like I am suffering with cough and I am suffering with running nose. There may be other symptoms that the patient may not be telling it to the doctor because he is not aware of, and it is the expertise of the doctor and the system to find out what exactly is not able to communicate. So the doctor says there is a guarantee that you are suffering with fever for 70%. So that 70% is your probability and that is your certainty or uncertainty measure. So mathematics is a vital foundation of AI because probability and uncertainty theory was discussed in mathematics. Even your fuzzy logic is a part of mathematics. Second important, most important component of the existence of AI, because most of the AI applications are now interacting with people in the terms of language. Even if some people remember when I am introducing a concept called as conceptual dependency, initially in the first week, I said I have a statement like see Rama is a boy, Rama is running. If I tell this statement in English, we have a representation. If I tell the same statement in Tamil also, we have a representation. If I tell this same statement in Telugu also, we have a representation. But you need to understand, artificial intelligence will have the same representation for any type of language. Whether you spoke in Chinese, or whether you speak in Telugu or any other language, the representation is same. So the linguistic part is very important. The linguistics part, we call it as natural language processing. How can you, a system can understand your language in the terms of grammar? Whether grammatically the system, this language is right. When the grammatically it is right, then what is the semantic of that statement? So linguistic talks about how do you structure a statement, what is the alignment of the statement, if you change the structure, what are the meaning changes, syntax and semantics. But most importantly, AI tries to have the same representation for the same meaning sentences uttered in different languages. AI try to build the same representation of knowledge for the same meaning sentences that were uttered in different type of languages, whether you spoke in Telugu or Tamil, if the meaning is same, the representation is same, then only your systems can process. So that is the reason the linguistic is a vital foundation of artificial intelligence. Then you need to think about this neuroscience. Neuroscience is a science which thinks about how does your brain functions, how does your brain responses. Is there any correlation between the brain activity and a human thought? See, that's what yesterday I said. I'm hungry. What is the response of the brain? That is the way in which your machine will also learn and function. So the interest of keeping this neuroscience is when you have a problem, we have a concept called neural networks. The problem will be represented in the terms of neurons. This is how your neurons is. See, this is how your brain is. Your brain is a collection of neurons. So how does this neurons gives the output to your brain? This is how your machine learning will learn, and it is going to it's going to function also. That is the reason neuroscience. What is the input? What is the response? What is the input? What is the outcome? What is the input? What is the action? If you wish to learn this theoretically, we need to have a subject called as neuroscience. Now, theoretical knowledge, if you don't have this neuroscience answer, there is no need, because this neuroscience was completely integrated in the terms of neural networks. Deep neural networks, we call it as DNN. So obviously, neuroscience theory is not needed for us. But the intention of keeping this as a foundation is we need to understand how this brain functions, and based on that, we have to go. So this is a control theory is the last foundation of AI, which is also important when you try to build robots. So when you design robots to perform different tasks, then what is that we do is the machines can change their behavior with respect to the response of your environment. So mathematically, we represent the robots in the terms of differential equations. So whenever the behavioral changes happen in a robot with response to the environment, so obviously we'll change some parameters in that equation so that this robot can be simulated by using your other differential equations. That is the reason control strategy, control theory is needed. This is a old way of doing. Now this robotics and RPA was done automatically without much programming. So the second part is very important. The second part, the linguistic part, is very, very important, because most of the applications that we design or we develop or most people using are pertaining to linguistic. If you remember properly yesterday, also I said we have many applications, voice assistants in the terms of Siri, Alexa, Google Home, many applications which people use. That's what yesterday I said. Kids are interacting with the system by using the voice. So we need to understand the structure of the voice, meaning of that, then you have to respond. So among the components of AI, this knowledge base is the mandatory component of AI. Without that, we cannot do anything. If you wish to introduce an AI app, you need to have a Firebase. That Firebase, you call it as a database, that is your knowledge base. So inference is the output of your system. Inference engine, what it will do is it will just find out whether with the input that is available, can you make some decision or not. Final decision is an inference. That inference sometimes is a guaranteed inference with 100% probability. Sometimes it is not guaranteed. There is a statement with some certainty. So control strategy is second vital important component of AI. The reason is we need to move from one state to other state with respect to the way in which you approach your goal. So last class is very important. That is the reason I have taken some time to explain what actually happened in the last class. So the next slide, we have a few questions that has to be answered. Can somebody unmute yourself and answer this? What is the functionality of control strategy in your components of AI?
Database.
control strategy is set of algorithms or classifiers which will make you to move from one state to other state. See, in a DFA, what is the purpose of transition function? Somebody can tell, any mission you have a transition function for what reason?
Move from one state to another state.
Yes, the same function your control strategy will do. See, yesterday, if you remember, I said I am suffering with cough for 2 days is the first state, and your system has asked a query like, what are the other symptoms you are having? Then I said I am suffering with cough for 2 days, plus I also have a running nose. This is your state 2. Then to take a decision, it has asked other query like, what are the other symptoms? I said I am suffering with cough, I am suffering with running nose, and also I am suffering with headache. This is the third state. Once you reach the third state, your system is able to take a decision. The decision is a fever. There is a chance that you have a fever. So who is making this movement is called as a control. Who is making this is a control strategy. So control strategy, you can visualize this control strategy in the terms of algorithm or a classifier. This is very important. Name some control strategies. Can you name some control strategies? Can you unmute yourself and talk? There's no problem.
Sir, BFS, DFS.
Yes, what you said is right. You have many algorithms called DFS, BFS, branch and bound, hill climbing, A-star algorithm, A-star algorithm in the syllabus. So whenever some algorithm was given, still some disturbance is there. You need to mute yourself. Hello? Okay. I need to mute. Okay, just I will. Okay. So I said name some control strategies. You can name any of the control strategy like BFS starting with A-star algorithm or A-star algorithm, but you need to understand like you have many sorting algorithms in the syllabus. Which sorting algorithm is better? Can somebody tell?
Quick sort.
See, quick sort, in worst case you can go to n square, is it right? Order of n square. But in merge sort, in worst case it will give n log n. N log n is better or n square is better?
And login.
Yes, what you said is right. N log n is better. See, when you try to select an algorithm, you need to think about the application where this algorithm is getting placed. So the same way, when you select a control strategy, you need to find out what application we are using, what is the data structure that you are using in behind, whether you are going for a tree or a graph, or you are using a array implementation, or whether you are using a linked list implementation. Based on that, you have to choose a control strategy. This discussion is enough. So does the database that you are talking in A will update with respect